Hello, dear sapiens. Whether you are lying down to rest, trying to quiet the noise of a long day, or simply walking with headphones through a busy city, welcome. This is Earth Stories, a place for gentle science and deep time, where we, clever apes that we are, still stare into the dark and wonder how we came to be here. So, take a slow breath. Perhaps you are preparing for sleep. Perhaps you are studying, driving through the night, or simply seeking a quiet companion. Wherever you are, this episode is made to meet you there. And if you drift off before the end, don't worry. Chapter markers are in the description so you can always return. The story is worth hearing whole. Tonight's journey takes us not thousands of years back, but millions. 66 million years ago, the sky was torn apart. A single asteroid, no larger than a city, struck Earth with the force of billions of bombs. In that instant, oceans rose, forests burned, and the great dinosaurs, rulers of the planet for more than 100 million years, fell silent. But the story is not only of endings. It is also of survival, of small mammals in burrows, of birds that flew, of reptiles that waited. From their endurance, a new world began. This is the story of the comet that erased an age and opened the path to us. 66 million years ago, the world was stable in a way that feels almost impossible to us. It had already weathered upheavals, continents drifting apart, mountain chains rising and eroding, seas opening and closing. Yet by the end of the Cretaceous, Earth looked like it had reached a rhythm, a long, warm heartbeat that pulsed across forests, rivers, and oceans. North America was split down the middle by the Western Interior Seaway, a shallow ocean that turned the continent into two separate landmasses. Along its shores stretched estuaries, mangroves, and tidal flats alive with fish, turtles, and giant crocodilians. Farther inland, wide floodplains carried herds of dinosaurs that grazed in endless cycles, leaving behind trampled paths that hardened into trackways we can still find today. The climate was warm, humid, and forgiving. No ice caps chilled the poles. Winters were brief and mild. Forests grew lush in regions that would later turn into deserts. Volcanic eruptions in India had begun to reshape the air and land, pouring lava across vast areas of the Deccan Traps. But ecosystems adjusted. The abundance of plant life was astonishing. Angiosperms, flowering plants, had spread across continents, filling the air with pollen, attracting swarms of bees, beetles, and moths. Ferns still thrived in shaded wetlands, while conifers rose like living spires in uplands. Dinosaurs flourished. Duck-billed hadrosaurs roamed in herds that may have numbered in the thousands. Their jaws held batteries of teeth, capable of grinding the toughest vegetation. Horned ceratopsians, such as Triceratops, moved in family groups, their frills and horns both weapon and signal. Armored ankylosaurs trundled through undergrowth, tails ending in clubs that could shatter bone. Tyrannosaurs, apex predators, stalked these herds with a mixture of patience and brute strength. Smaller raptors, feathered and agile, darted through forests in coordinated packs. Even the skies were full. Pterosaurs, winged reptiles with spans longer than small planes, glided across coasts, their hollow bones perfectly adapted for riding thermals. Birds, descendants of dinosaurs themselves, had already diversified. Some perched in forests, others dove into lakes, testing every niche the sky offered. And beneath the seas, life thrived in equal measure. Mosasaurs patrolled the depths with serpentine bodies and powerful tails. Plesiosaurs, with long necks and paddle-shaped limbs, hunted fish in shallow bays. Ammonites, cephalopods with coiled shells, drifted in dazzling variety, their forms curling like frozen storms. Coral reefs hosted communities of invertebrates, fish, and crustaceans. Sharks, survivors of earlier extinctions, slipped silently between worlds. This was not a fragile balance. It was robust. Diversity was high, food webs were complex, and ecosystems were resilient to local shocks. Droughts, floods, and volcanic ashfalls came and went, but life recovered. For more than 150 million years, dinosaurs had faced challenges and endured. They were not fading when the end came. They were thriving. If you could stand on that ancient earth, your senses would have been overwhelmed. The air was thicker with oxygen than ours, rich with the scents of resin, damp soil, and the sweet rot of fallen fruit. Cicadas thrummed in the canopy. Dragonflies skimmed pools, wings catching the sun. Herds of hadrosaurs filled valleys with low, honking calls, communicating across distances like foghorns of flesh and bone. Predators responded in kind. The roar of a tyrannosaur, deep and resonant, would have carried for kilometers, warning rivals as much as it threatened prey. Packs of smaller raptors chirped and barked to each other, feathered bodies flashing between trunks. Even when no predator was visible, the forest carried the hum of awareness, ears twitching, heads lifting, tails stiffening at sounds half heard. At night, the sensory palette shifted. Insects ruled the soundscape. Mammals, mostly small and nocturnal, emerged from burrows to forage. Their world was one of keen noses and cautious steps. They hunted beetles, dug for roots, sniffed out fallen seeds. They lived under the notice of dinosaurs, shadows within shadows. Waterways were just as alive. In the western interior seaway, schools of fish flashed like silver storms. Mosasaurs patrolled with effortless confidence, jaws full of conical teeth. Plesiosaurs arched their necks to snatch fish from below. Along muddy banks, turtles basked in the sun, while crocodilians slid noiselessly into the shallows. Every surface, every niche was filled. Volcanoes provided punctuation, not dominance. Eruptions darkened skies for months, then cleared. Forests regrew. Rivers shifted. Floodplains drowned, then dried. But life returned. Fossil soils from this time show roots and pollen layered in cycles, each one proof that ecosystems recovered again and again. The Mesozoic Earth was noisy, fertile, resilient. No creature knew it, but they were living in what would later be called the twilight of the dinosaurs. To them, it was simply the present, abundant food, familiar rivals, predictable seasons. What made the world stable was not stillness, but balance. Energy flowed smoothly from plants to herbivores, from herbivores to predators, from decay back into soil. This flow had persisted for millions of years. Every hatchling, every bud, every new life was a continuation of rhythms older than mountains. From our perspective, it was a golden age, the culmination of reptilian dominance. From theirs, it was simply life as it had always been. No shadow on the horizon suggested otherwise. The sky was still only a roof, not a threat. The fossil record confirms this impression of continuity. Below the KPG boundary, sediments are thick with evidence of thriving ecosystems. Riverbeds preserve trackways where three-toed feet pressed into mud. Nesting sites hold the outlines of eggs and the tiny bones of hatchlings. Leaf impressions record the spread of angiosperms, their veins delicate yet clear after millions of years. In ocean cores, the shells of foraminifera, microscopic creatures, stack layer upon layer, testifying to stable seas. Nothing in these archives suggests impending crisis. Mammals remained in the background, but even they were diversifying. Tiny jaws, teeth sharp and intricate, show insect eaters, seed nibblers, burrowers. They filled the underbrush with quiet industry. Their bodies were small, but their potential vast. Yet in this moment, they were only minor notes in the orchestra of the Mesozoic. Dinosaurs held the melody. It is tempting to imagine that some creatures sensed change, but nature does not give warnings of cosmic accidents. A triceratops grazing on cycads had no way to know that its lineage was approaching an abrupt end. A mosasaur cruising through warm waters could not guess that its seas would soon turn barren. A mammal burrowing for insects did not know it was living on the edge of opportunity. For all of them, life was simply now. The Mesozoic Earth seemed eternal. Dinosaurs had already ruled for a span of time far longer than humans have existed. They were not in decline. They were not losing battles to younger species. They were successful, diverse, strong. The age of reptiles looked as if it would continue forever. And yet, stability is always an illusion. Balance holds until something larger tips the scale. In this case, the tipping point was not on Earth at all. It drifted silently in space, indifferent to the lives it would erase. Far beyond their sight, an asteroid 10 kilometers wide traced its orbit around the sun. For millions of years it had wandered, unnoticed. With each pass, its path bent closer to Earth. No creature looked up to see it. No forest trembled at its approach. The dinosaurs lived in a world that felt unshakable. But above them, unseen, the sky was already carrying their ending. Long before the last hatchling broke out of a leathery egg, the cause of an ending was already moving, far from all the warmth and water of Earth. The asteroid was not a villain and not a messenger. It was a leftover, stone and metal fused in the crowded nursery where planets once collided and clung together. For ages it kept to its lane, one dim fragment among millions, circling the sun on a path as uneventful as sleep. Space, though, is not still. Gravity has the patience of mountains and the precision of a clock. A distant tug from Jupiter here, a subtle nudge from Saturn there, a whisper of sunlight warming one side of the rock more than the other, bleeding heat away and ever so slightly adjusting its spin and drift over millions of years. None of these forces shout. They add up like tiny edits in a manuscript, changes so small no reader would notice, until the ending is different. Its orbit shifted from safe to intersecting by degrees too fine for any eye to see. The numbers were simple, angles, velocities, periods, but the implication was not. A path that had always missed would, on one particular return, not miss. That is all destiny is in a cosmos like ours, geometry that finally closes a gap. From Earth, there was no prophecy, no omen. The great inland seas breathed in tides, forests turned light into sugar, herds flowed across floodplains. In the sky, pterosaurs folded and opened their wings to ride invisible elevators of warm air. The asteroid knew none of this. It did not aim. It moved. At last, its course carried it close enough that the night acquired a new star. At first, a faint salt grain of light on black cloth, far from the moon and indifferent to constellations, it kept coming. Unlike stars, it did not shimmer in Earth's air. Unlike comets, it trailed no ghostly tail of ice. It simply brightened with a steady, almost clinical certainty, a point that would not blink. Nights passed. The point grew. The difference between distant and near is mostly a matter of time. The difference between harmless and catastrophic is sometimes only a matter of minutes. The wanderer had found a crossing where Earth would be, not where Earth had been. 2 bodies, 2 clocks, 1 appointment no creature had scheduled, and none could cancel. The light entered the story before its meaning did. That is how catastrophes begin for the living, as things that are merely unusual. The bright point returned night after night, climbing the same arc, only larger. It surpassed the evening star. It rivaled the moon. Shadows formed where shadows never stood before, between tree trunks at midnight, along the flanks of resting hadrosaurs, on the crests of dunes that had only ever known darkness and wind. Rivers caught the glow and braided it across their surfaces so that even nocturnal eyes flinched. No mind on Earth framed a question that fit what was happening. Instinct treated the change as weather. Be alert, then get on with it. Birds shifted uneasily on their perches and tucked their heads again. Pterosaurs wheeled once to test the light and rode a thermal toward the coast, uninterested in answers. Small mammals paused at the burrow mouth when the ground gleamed faintly and then nosed out anyway, drawn by the smell of beetles. A tyrannosaur lifted its skull from a cooling kill and looked up for a beat no longer than a breath, then returned to the work of tearing flesh. Attention is a currency life spends carefully. Yet the light unsettled the clock of the world. In forests, some flowers that trusted the length of night to cue their opening fumbled their timing. Moths arrived early or late to find nectar waiting or already gone. Along shorelines, the glow smudged the border between night and dawn. Silhouettes moved in the wrong half-light, and for a moment even predators hesitated at these unfamiliar shadows. Insects that sang only when the dark was complete took a measure of the sky and began anyway, or didn't, and the chorus shifted. The seas, which keep their own counsel, mirrored the change without comment. Far offshore, the surface glittered with silver scales and tiny sparks of bioluminescent plankton that flared when shoals turned. Below, Mosasaurs ghosted through the dim like moving reefs. None of them looked up. None of them needed to know that a point of light was a body, and a body had mass, and mass at speed becomes an argument that biology cannot win. By the final week, the glow was oppressive. It erased faint stars and pulled the eye whether or not the eye wanted it. The horizon wore a smear of false dawn in the wrong direction, a brightness that rose as the real sun set, so that for a few disturbed hours there were two sources, two slants of shadow, two competing truths. Day and night did not exchange places. They blurred. Rest grew shallower. Foragers ranged at odd times. Nest guards blinked more often, and vigilance frayed. But the rules of a world are slow to break from within. Leaves still made sugar by day. Predators still measured wind direction and the angle of cover. The deep pattern of life held even as the sky scribbled something new across it. No signal spread through the forest that said, "This is not weather." No shared alarm evolved for descending star. The growing light was a question with only one answer, and the answer was coming too fast for comprehension. There comes a point when a star in the eye becomes a thing in the world. The change is sudden because the last stretch is short. On that last night, the point thickened into a bead, the bead into a spear, the spear into a sunless sun with a tail of incandescent air. The asteroid entered the atmosphere not like a visitor, but like a blade. At hypersonic speed, the air could not move aside. It compressed, and compression made heat. The bow shock in front of the rock turned sky to plasma, matter stripped toward light. For a heartbeat-long eternity, the fireball outshone the day star that ruled the planet. Forests threw knives of shadow across ash-white clearings. The western interior seaway flashed a hard metallic glare and then seemed to boil where the reflection lay. Sound trailed light. Pressure waves outran thunder and rattled trunks and ribs and the cavities of skulls before any roar arrived. Birds lifted with one mindless impulse, as if flight could escape light. Herds bunched and surged, their own mass turning against them when panic struck an uneven landscape. Even the calm patience of crocodilians broke. They slid from banks with the urgency of creatures who had never rushed. Fragments sloughed from the incandescent skin of the rock and streaked ahead as lesser meteors, a cruel rehearsal scattering sparks across horizons. A thin, harsh smell, ozone and burning dust, ran before the shock. In the narrow reaches of canyons, air shoved like a hand. On open flats, the surface wind fell inward, toward a point no creature could parse, the world's breath drawn in. The geometry of disaster is simple. A body moving fast cannot stop. A planet rotating under it cannot move aside. Between them is only distance, and distance was almost gone. The asteroid's diameter was small by the measure of continents, and still it filled the sky like a horizon that had come loose and fallen. This is the moment life has no language for. Evolution writes for drought and flood, for winter and heat, for teeth and talon. It does not write for the roof itself descending. A hadrosaur's wide eyes, a tyrannosaur's vast jaw, a mammal's quick heart. All of them beat in a rhythm that said, run, hide, fight, endure. None of those verbs applies when the problem is the sky. The fireball crossed the last span in less time than a breath. Ahead of it, waves steepened on distant shores, as if the ocean had heard the news early. Behind it, the trail of ionized air cooled in glittering tatters that fell like a constellation coming apart. There is no safe cliff to stand on in this paragraph, no vantage at a distance, only a world that had been old and sure of itself, and a stone that had been quiet and sure of nothing, closing the last remaining gap. The sea off the Yucatan lay shallow and warm, unaware that it was about to become a lens for energy the planet had no practice absorbing. The coastlines did not brace. The forests did not bow. One more heartbeat, then contact, and after that, a different Earth. The asteroid struck with more force than any event in the memory of the planet. At 20 kilometers per second, its kinetic energy was equal to more than 100 million megatons of TNT, several billion times the power of the bombs humans would one day build. If every volcano on Earth had erupted at once, if every earthquake had convulsed simultaneously, the sum would still have been less than the energy released in that 1 second. The ocean at the impact site was shallow, a warm shelf sea. In an instant, thousands of cubic kilometers of water vanished into vapor. The rock beneath, granite and limestone formed over hundreds of millions of years, behaved like liquid. Shock waves drilled downward, fracturing crust and mantle. In the chaos, the ground rebounded, creating a central peak higher than Mount Everest before collapsing again. That peak froze in place as part of the peak ring, still buried deep beneath Yucatan, mapped by geologists in our own time. The temperatures at ground zero exceeded 10,000 degrees Celsius, hotter than the surface of the sun. Molecules split, atoms rearranged. Elements fused into strange new forms that only occur under catastrophic compression. In drill cores today, geologists find glassy impact melt and shocked quartz crystals, their lattices distorted like frozen screams at the atomic scale. For life nearby, there was no struggle. Dinosaurs grazing, pterosaurs gliding, mosasaurs surfacing for breath, all vanished in the same moment. The air itself was a weapon. Pressure waves so intense that lungs collapsed, bodies were thrown, forests turned to tinder. At distances where sight still carried the flash, heat alone could ignite flesh. Seismic waves radiated outward at thousands of kilometers per hour, rattling crust like the skin of a drum. Across North America, swamps sloshed, rivers surged backward. Even half a world away, the impact registered like a global quake, as if Earth's bones themselves had been struck. The first second rewrote the planet, but the violence had only begun. From the blast zone, air and water fled outward in concentric rings of destruction. Winds scythed across coasts at speeds greater than any storm recorded. Whole forests fell as if a giant had pressed a hand flat across the land. Trees snapped, stripped, and ignited in the same motion. The ocean rose in walls kilometers high. Tsunamis shot across the Gulf of Mexico and beyond. Within an hour, waves taller than skyscrapers slammed into the shores of Texas. Inland seas surged backward and forward, leaving behind layers of sand and broken shells in places hundreds of kilometers from the modern coast. In the Caribbean, islands were scoured bare, their soils dragged out to sea. Some waves leapt entire archipelagos, crashing down with a roar that no living creature could survive. The geological record preserves this chaos. In southern North America, a layer of event deposits captures a jumble of fossils. Marine shells mixed with land plants, boulders tumbled and rolled into places they should never be. In some sites, tree trunks lie snapped and waterlogged, entombed in sediments alongside shark teeth and ammonite shells. Only a flood of oceanic scale could have made such a mixture. The sound alone would have been a global terror. The crack of the initial impact rolled outward as a wave of thunder that circled the earth multiple times. To ears sensitive enough, it would have seemed endless, a horizon roaring again and again, never still. In the crater, the sea boiled. Superheated steam burst upward into the sky. Limestone vapor mixed with water to form sulfur gases, a chemical wound that would scar the atmosphere for years. The Earth's crust was no longer solid, but a wound, bleeding heat and ash into the air. And still the planet was not done. What went up had to come down. Trillions of tons of rock had been thrown into space. Some fragments arced around the planet and fell within hours. Others circled the globe before descending. As they re-entered the atmosphere, they ignited. For hours, perhaps a full day, the sky blazed with falling stars, not the harmless streaks we know, but a deadly rain of molten glass. Tiny spherules, droplets of once molten rock, glowed red as they fell. Billions upon billions of them re-entered, heating the air until the lower atmosphere itself became a broiler. Forests erupted into fire across entire continents. Charcoal layers found in Cretaceous Paleogene sediments confirm this. A global wildfire, not localized burns. Ash clouds ballooned into the stratosphere, blotting out light even as they carried the chemical memory of flames. Animals that had survived the blast or the waves now faced heat without refuge. Fires leapt across grasslands and forests alike. Herds that fled found no safety. Smoke choked lungs. Flames advanced faster than their legs. Even burrowing creatures felt the sear of heat above. Only water, soil, or sheer luck offered protection. The rain of glass was followed by acid rain. Sulfur aerosols, born from vaporized rock, combined with water to fall as diluted acid across continents. Leaves browned, soils leached of nutrients, lakes turned corrosive. This chemical assault reached even into places far from the crater. And then came the darkness. Dust and soot spread into the stratosphere where rain could not wash them away. Within weeks, the planet dimmed. Sunlight struggled to reach the surface. Temperatures plunged. Photosynthesis faltered, then failed. The impact had unleashed its trilogy of ruin: fire, water, and air. Each one alone could have been a catastrophe. Together, they reshaped the biosphere in hours. When the fireball faded and the waves subsided, Earth was left shrouded, wounded, waiting for the long night to begin. When the shock waves faded and the mega tsunamis lost their height, the real catastrophe unfolded in silence above. The sky itself had become poisoned. Every fragment of soot from global wildfires, every grain of pulverized stone ejected from the crater, every aerosol droplet born from vaporized sulfur combined to form a veil that stretched across hemispheres. This was no passing cloud. It was a planetary shroud. The particles rose high, lofted into the stratosphere by the violence of the impact. Once there, they lingered. Rain could not reach them. Winds only carried them farther, faster. In a matter of weeks, the veil spread worldwide. From any place on Earth, day dimmed to a weak twilight, and night disappeared into a deeper black where even stars were erased. The sun itself shrank to a pale disk, blurred and discolored. Midday felt like dusk. Shadows weakened. Temperatures began to fall. But the most immediate effect was the failure of light. Photosynthesis, the quiet, constant process that turned sunlight into life, stumbled and stopped. In forests, leaves yellowed, then dropped. Shoots withered before they could reach for light. In grasslands, nothing sprouted. Crops of the age, ferns, cycads, angiosperms, halted their growth in unison. In oceans, the change was just as brutal. Sunlight normally penetrates the upper layers of seawater, feeding plankton that form the base of the marine food chain. With the surface dimmed, plankton populations collapsed. In sediment cores today, this moment is visible. Layers that had been rich with microscopic shells suddenly turned sparse, their fossils gone, replaced by empty silt. On land, another record remains: the fern spike. Across the globe, after the fires, pollen counts plummet. Then spores of ferns appear in overwhelming abundance. Ferns thrive where others cannot, colonizing landscapes stripped bare by fire or ash. Their sudden dominance is a signature of planetary trauma. This evidence confirms what the world experienced. Earth was entering a night not of hours, but of years. A night where light itself could not be trusted. The loss of sunlight reshaped climate in weeks. Without energy from the sun, Earth cooled with astonishing speed. Global temperatures fell by as much as 10 to 15 degrees Celsius. The tropics, once hot and wet, grew chill and dry. Regions that had never known frost now saw ice crusting across leaves and soil. At higher latitudes, snowfall arrived in seasons that had never carried it before. This sudden cold struck hardest at large animals. Dinosaurs, built to consume tons of vegetation each year, faced landscapes stripped bare. Hadrosaurs, whose jaws once ground endless leaves into pulp, wandered through skeletal forests with nothing to eat. Triceratops, once able to defend against any predator with horns and frills, found themselves powerless against hunger. Sauropods, already rare, succumbed swiftly. Their immense bodies, marvels of engineering in an abundant world, became liabilities in a starving one. Predators followed. A tyrannosaur could overpower prey, but prey was vanishing. Fossil records from the final Cretaceous layers show signs of stress, bones with slowed growth rings, evidence of starvation. Some skeletons even carry marks of cannibalism, apex predators driven to hunt their own kind. The silence that fell was as devastating as the cold. Plains once thundered with herds grew empty. The air, once shaken by the wing beats of pterosaurs, stilled. Even insects faltered, their buzzing fading as plants failed and carrion rotted away. In oceans, ammonites disappeared entirely. These iconic coiled cephalopods had survived multiple extinctions before, but without plankton to support them, their lineage ended. Marine reptiles followed. Mosasaurs and plesiosaurs vanished, their dominance of the seas over. Coral reefs bleached and crumbled, their architects unable to withstand the sudden cold and acidifying waters. Fish populations dwindled. Only sharks, ever adaptable, endured, though their numbers thinned. The soundscape of Earth transformed. Where once choruses of life overlapped, the honks of hadrosaurs, the roars of predators, the chatter of raptors, the trill of birds, there was only wind over empty ground, ice cracking on rivers, the occasional snap of a dying tree. The long night was more than an image. It was literal, lived silence and frost that erased abundance and replaced it with absence. Extinction is rarely instantaneous, it arrives in waves. The asteroid had delivered the first blow with its impact, fires and shockwaves. The second blow came with the darkness and the cold, and then the cascade began. When plants died, herbivores starved. When herbivores starved, carnivores fell. When prey and predators both vanished, scavengers and parasites followed. Every link in the chain pulled another into collapse. By the end of this sequence, 3 out of every 4 species on Earth were gone. Entire families of animals disappeared: horned dinosaurs, duck-billed dinosaurs, ankylosaurs, raptors, pterosaurs, the masters of the air for over 150 million years, left no descendants. In the seas, ammonites and giant marine reptiles ended their dynasties. What survived were the adaptable, the hidden, the patient. Mammals, small and furtive, dug deeper into burrows, their diets flexible enough to switch from insects to seeds to carrion. Birds, particularly seed eaters, endured by living on reserves that outlasted the worst years. Crocodiles, with their amphibious habits and slow metabolisms, waded in rivers and lakes. Turtles, encased in shells and adapted to pond life, endured the freeze. The fossil record preserves this collapse vividly. In many sites, dinosaur bones appear in abundance below the boundary, then vanish entirely above. Ammonites cease suddenly in marine sediments. Coral diversity plummets, and across land sites worldwide, spores of ferns bloom briefly in dominance, a botanical banner planted on the graves of forests. But collapse was not total. Life persisted in fragments. Seeds lay dormant in soil, waiting for warmth. Insects, though diminished, hatched anew in cycles. Some mammals gave birth in their burrows, ensuring continuity even when the surface was barren. The long night was both an end and a threshold. It closed the Mesozoic era, the age of dinosaurs, in fire, ash, and silence. But in the quiet that followed, the stage was cleared for what would come after. Life had bent, nearly broken, but not vanished. The curtain had fallen on one age. The next waited in the wings, ready to step into the fragile light when it returned. In the twilight world after the impact, the greatest weakness of the giants was their size. For millions of years, mass had been their advantage. A hadrosaur's enormous gut could process tons of vegetation. A sauropod's towering neck could sweep trees clean. A tyrannosaur's bulk allowed it to dominate every rival. But now, every kilogram of flesh demanded food the planet could no longer provide. The forests, once endless buffets of green, were skeletons. Leaves had fallen and not returned. Branches were stripped bare. The ground held only ash, char, and frost. For herbivores, this was a death sentence. Hadrosaurs, the duck-billed grazers that once filled floodplains in thundering herds, searched in vain. Their complex batteries of teeth, perfect for grinding tough plants, had nothing to grind. Fossil evidence shows their growth rings narrowing in the last days of the Cretaceous, a biological record of starvation written into their bones. Predators fared no better. A tyrannosaur could overpower almost anything that walked, but almost anything no longer walked. Carcasses littered the land in the first weeks, but scavenging is a race against time. Within months, bodies rotted or burned. The great hunters turned on one another. Paleontologists have found tyrannosaur bones scarred with the bite marks of their own species, grim evidence that even kings of the Cretaceous ate their own kind to survive. Small creatures had options: seeds, roots, insects, burrows. Giants had none. Their bodies required scale. In a shrinking world, scale was the enemy, and so hunger hollowed them out. Herds grew thinner, then scattered. Tracks that once carved floodplains by the hundreds now appear alone, a few individuals staggering where multitudes once passed. The land grew quieter, emptier, as the giants starved in plain sight of their own former abundance. The sounds of the Cretaceous were fading. Once, low honks of hadrosaurs rolled across valleys, answered by the trumpeting calls of ceratopsians. Once, the air trembled with the wing beats of pterosaurs, their cries echoing over coasts. Once, the roar of a tyrannosaur carried for kilometers, a declaration of supremacy. Now those sounds were vanishing, replaced by silence broken only by the wind. Imagine a lone triceratops, its frills scarred from battles long past. Once it moved within a herd, horns lowered in unity against predators. Now it wandered alone, ribs visible beneath skin, its heavy body dragging step by step. When it bellowed, the sound went unanswered. Fossil evidence shows isolated individuals at the very top of the record, lonely survivors in a world already gone. Predators, too, gave their last calls. A juvenile tyrannosaur, ribs protruding, lifted its head and roared into emptiness. The sound echoed, but no prey stirred, no herd shifted. It was not the voice of power, but of futility. Even the skies lost their chorus. Pterosaurs, those aerial rulers since the Triassic, dwindled. Some of the last were massive ajdarchids with wingspans over 10 meters. Yet they too depended on abundant fish and small prey. With ecosystems unraveling, their calls died out. By the time the dust cleared years later, none remained. In the oceans, the ammonites, the cephalopods whose shells curled in spirals, had been abundant for hundreds of millions of years. They vanished completely. Their shells, preserved in limestone beds, end abruptly at the boundary, a record of silence in stone. The last roars of the dinosaurs were not a single moment, but scattered cries across continents. Each one was swallowed by the growing quiet, until even echoes failed. By the close of the Cretaceous, the giants were gone. Their absence is written not in myth, but in rock. Paleontologists call it the KPG boundary, a thin layer of clay enriched in iridium found on every continent. Below it, fossils of dinosaurs and ammonites and pterosaurs abound. Above it, they are absent. The line is stark, one of the clearest divisions in Earth's history. Entire lineages ended: sauropods, the long-necked titans; ceratopsians, the horned defenders; hadrosaurs, the plains grazers; ankylosaurs, the armored tanks; tyrannosaurs and raptors, the predators that once shaped ecosystems. None survived. In the skies, pterosaurs perished. In the seas, mosasaurs and plesiosaurs died with the ammonites. The age of reptiles, which had lasted more than 150 million years, ended in less than a geological heartbeat. It is important to remember, dinosaurs did not fail. They were not in decline. Right until the end, they were diverse and successful. Their extinction was not slow replacement by mammals or gradual weakness. It was an abrupt cut, imposed from outside. The asteroid ended them, not inevitability. What remained was emptiness. Ecological niches that had been stable for millions of years stood vacant. Predator-prey dynamics collapsed. Forests regrew slowly, first with ferns, then with flowering plants. Oceans recovered plankton by degrees. But the giants were never replaced. Their absence was permanent. From this void, mammals would rise. Birds, the only surviving dinosaurs, would diversify. But those are stories of beginnings. Section 5 belongs to endings. The last giants fell not to drought or rivals, but to the sky. Their reign had been longer than any human empire could dream of, yet it ended suddenly, absolutely. In their silence, the age of mammals waited to begin. When giants fell, the small inherited the night. Mammals, never dominant through the Mesozoic, had always lived underfoot. Most were shrew-like insectivores, no larger than a rat, with sharp teeth for beetles, seeds, and roots. They had been background actors, darting between fallen logs, tunneling into soil, foraging under darkness while dinosaurs owned the day. It was exactly these habits that saved them. Small bodies required little food. Where a hadrosaur needed tons of vegetation each year, a rodent-sized mammal could survive on seeds cached underground or insects overlooked by predators. When forests burned, they retreated into burrows. Fossil evidence of early mammals shows enlarged inner ears and flexible spines, traits perfect for moving unseen through tight, hidden spaces. Their homes became their shields against the storms above. Dietary flexibility gave them another advantage. Herbivores starved when plants withered. Carnivores died when prey vanished. Mammals could switch diets. Seeds, roots, carrion, insects, all were viable. Even fungi growing on decaying wood provided calories. Some paleontologists suggest mammals gnawed charred plant matter in the aftermath, their strong jaws extracting nutrition from what giants could not use. Their reproductive strategy was equally key. Dinosaurs invested heavily in clutches of eggs, some guarded for months. Mammals bred quickly, with short gestation and multiple litters a year. Even if many young perished, enough survived to carry the lineage forward. In extinction, time is a currency, and mammals multiplied it. Fossil jaws and teeth confirm their persistence. Below the iridium-rich KPG clay, mammalian diversity was modest. Above it, small jaws and molars continue. They had shrunk in number but not vanished. In fact, some lineages show hints of rapid radiation immediately after the catastrophe, as if released from ecological prisons. The long night silenced the giants, but the whispers of mammals carried on, scurrying, digging, squeaking, fragile sounds that would one day crescendo into dominance. Survival did not belong only to mammals. Ancient reptiles endured too, not through power but through patience. Crocodiles, already ancient by the end of the Cretaceous, had survived 200 million years of upheaval. Their secret was restraint. They could lower their metabolism and weight, surviving weeks or even months without feeding. When ecosystems collapsed, crocodiles floated in rivers and lakes, conserving energy. Water protected them from heat and fire, while their amphibious habits let them exploit both land and aquatic prey whenever available. Fossil crocodilians remain in sediments above the boundary, proof that patience outlasted catastrophe. Turtles carried another formula for endurance. Encased in armor, they were slow but secure. Many lived in freshwater habitats buffered from surface chaos. Their diets, plants, carrion, insects, were flexible. Eggs buried in sand sometimes failed, but enough hatched. Shell fragments above the KPG clay testify to their persistence. Today's turtles are living fossils, descendants of those that slipped quietly through the bottleneck. Birds too survived, but not all. Many ancient lineages vanished alongside their dinosaur kin. The survivors were small, ground-dwelling species with diets rich in seeds and insects. Seeds stored energy through the darkness, allowing birds to eat when greenery failed. Fossils show that modern bird lineages trace back to these modest survivors. Every sparrow, crow, and eagle alive today carries in its bones the story of that endurance. Sharks and fish also endured. In deep oceans, some ecosystems depend not on sunlight, but on chemical energy from vents. These refugees insulated species from collapse at the surface. Sharks, adaptable and ancient, continued as they had since before the dinosaurs. Their teeth scatter both below and above the boundary line, one of the few continuities in a world otherwise severed. The survivors shared traits: flexibility, resilience, patience. They were not the most powerful. They were the most adaptable. The age of reptiles ended not because reptiles could not survive, but because only certain kinds of reptile could. And so scales and shells joined fur and feathers in carrying life across the abyss. Life persisted not only in bodies, but in seeds. Plants had suffered brutally in the long night, but evolution had armed them with strategies of pause. Seeds encased in shells, capable of lying dormant for years, waited through darkness. Some had thick coats that protected embryos from cold and drought. Others required disturbance, fire, frost, or bare soil to trigger growth. The catastrophe provided all three. When light returned, even weakly, these seeds sprouted. Hardy ground cover species and low shrubs stabilized soils, while fungi and insects worked as early recyclers of nutrients. Over time, a broader variety of flowering plants reestablished themselves, a process recorded in fossil pollen charts as ecosystems stitched themselves back together. Insects mirrored the plants. Many lay eggs resilient to drought and cold. These hatched when conditions improved, restarting the cycles of pollination and decomposition. Beetles, ants, and flies became engineers of recovery, stitching together the frayed threads of ecosystems. For the survivors, each shoot and hatchling was lifeline. Mammals foraged seeds, birds cracked shells with beaks, turtles nibbled shoots at pond edges, crocodiles returned to snatch fish as streams refilled. The food web rewove itself strand by strand, fragile but functional. Geological evidence records this renewal. Above the iridium clay, pollen counts rise. Fossil insects reappear. Small mammal teeth diversify. It is a record not of immediate triumph, but of persistence. The Earth had lost much, but it had not lost everything. What endured was enough. Enough to restart forests, to restock rivers, to repopulate skies with wings and songs. Enough to hold the possibility of future ages. The survivors did not know they were survivors. They were not victorious, only persistent. But persistence was enough. And from persistence, the story of all later life, including ours, would unfold. If you walk today along certain cliffs, chalk in Denmark, limestone in Italy, shale in North America, you might find it. A band of clay no thicker than your hand. To an untrained eye, it is unremarkable, a smear between pale layers of rock. But this thin horizon marks the most famous boundary in Earth's history. Below it lie the remnants of the Cretaceous world. Sediments are packed with the shells of ammonites, the pollen of diverse forests, the bones and teeth of dinosaurs. It is a world rich and crowded, layer upon layer recording abundance. Above it is a different planet. Fossils of dinosaurs vanish abruptly. Ammonites are gone. Pterosaurs never return. In their place are new forms, tiny mammal teeth, turtle shells, primitive birds. The flora, too, changes. Fern spores dominate for a brief pulse, evidence of scorched landscapes being reclaimed by pioneer plants. This line is called the KPG boundary. K for Cretaceous, from the German Kreta, meaning chalk, and PG for Paleogene. It is one of the sharpest dividing marks in all geology. It is not spread over millions of years, but pressed into a few centimeters of clay. The clay itself holds secrets. In 1980, scientists discovered it was enriched with iridium, an element rare in Earth's crust, but common in asteroids. Measurements revealed concentrations hundreds of times higher than background levels. The fingerprint of something extraterrestrial was smeared into that thin horizon. Everywhere geologists look, on every continent, on ocean floors, the line is the same age, about 66 million years. It is the geological equivalent of a scar that circles the globe, perfectly synchronized. To place your hand upon it is to touch the exact moment the age of dinosaurs ended. The boundary clay is more than iridium. Under a microscope, it reveals other clues born in fire. Tiny glass beads, called spherules, are scattered throughout the layer. Each is a droplet of rock that melted in the asteroid's fireball, was thrown into the sky, and cooled while falling back to Earth. Perfectly rounded, sometimes hollow, they glitter under magnification like frozen raindrops of stone. Their abundance tells us of the unimaginable heat that fused crust and ocean into molten spray. Mixed with the glass are grains of shocked quartz. Quartz normally arranges its atoms in neat, repeating lattices. But when subjected to pressures millions of times greater than normal, pressures equivalent to nuclear detonations, those lattices twist and fracture. The result is a crystal that looks ordinary until viewed under polarized light, when its interior reveals distorted stripes, scars of impossible violence. Such quartz has been found in nuclear test sites and meteor craters. Its presence in the KPG boundary is irrefutable evidence of impact. There is also soot, microscopic particles of carbon. In boundary layers worldwide, charcoal fragments appear. They testify that forests burned not just locally but globally. Fires swept continents, ignited by the rain of falling debris, and the superheated atmosphere. Some sediments contain more soot than any natural wildfire today could produce. It was not an ordinary fire. It was Earth itself ablaze. Each of these materials tells part of the story. Iridium points to an extraterrestrial source. Spherules capture the moment of rock turned liquid. Shocked quartz preserves the pressure of collision. Soot records the forests that burned afterward. Together, they form a chorus of evidence that sings the same refrain. A rock from space struck Earth and remade life. The clay is not lifeless. It holds, in its mix of minerals and carbon, the last whispers of a biosphere erased. It is a tombstone written not in words but in elements. The Earth keeps archives not in books but in layers. Sediments settle, year by year, leaf by leaf, shell by shell. They compress into pages written in mud and stone. To read them requires chisels, microscopes, and imagination, but once decoded, they tell stories more precise than any myth. The KPG boundary is one of the clearest stories. In marine cores drilled from the Atlantic and Pacific, foraminifera, tiny plankton with delicate shells, abruptly disappear. Below the boundary, dozens of species thrive. Above it, only a handful remain, smaller and simpler. It is as if the ocean's libraries were burned, leaving only pamphlets in place of encyclopedias. On land, pollen records shift dramatically. Rich forests of the late Cretaceous vanish, replaced briefly by fern spores in overwhelming dominance. Then slowly, diversity rebuilds as angiosperms return. Fossil soils record this sequence as blackened bands overlain by horizons studded with spores, nature's restart button pressed in green. In riverbeds of North America, dinosaur fossils crowd the strata below the boundary. Above it, there are none. Not one. The silence is geological as well as biological. In its place are new remains, small mammals, birds, crocodiles, turtles. The transition is not gradual. It is a cliff. For scientists, this boundary is more than evidence of a past disaster. It is a key to understanding extinction itself. Catastrophe, once thought improbable, is written clearly in stone. It reminds us that stability can vanish overnight, that the age of giants ended not with slow fading but with a sharp break. Standing at a cliff in Gubbio, Italy, or peering into a drill core from the Gulf of Mexico, we touch that break with our fingers. It is humbling. Beneath that line, the world is familiar in its abundance. Above it, a new world struggles to begin. The stone remembers, even when memory and flesh is long gone. It remembers the day the sky fell, the forests burned, and silence claimed the giants. And through it, we remember too. In the late 1970s, a geologist named Walter Alvarez worked in the hills near Gubbio, Italy. The cliffs there are a geologist's dream. A clean, continuous stack of limestone beds, each layer laid down by ancient seas like the pages of a book. By tracing the layers upward, Alvarez could read millions of years of uninterrupted history. It was there, in a narrow band of clay no thicker than a hand, that he noticed something odd. Below the clay, fossils of foraminifera, microscopic plankton, were abundant and diverse. Above it, they were sparse and simple. This clay marked the same boundary paleontologists had puzzled over for generations, the point where the dinosaurs and many other creatures disappeared. Alvarez wanted to know how much time that clay represented. Was it deposited over thousands of years or millions? If it were long, perhaps it recorded a gradual extinction. If short, something sudden. To answer, he turned to his father, Luis Alvarez, a Nobel Prize-winning physicist known for his bold ideas. Together with chemists Frank Asaro and Helen Michel, they tested the clay for rare elements. The results astonished them. The clay contained iridium in concentrations far higher than normal, hundreds of times above background. On Earth's surface, iridium is scarce. It hides deep in the core. But in asteroids, it is common. The team realized they were holding evidence of something extraordinary, debris from a cosmic impact, dust that had spread across the globe and settled into sediments. The extinction of the dinosaurs, they proposed, was not a slow decline. It was a catastrophe. In 1980, they published their results. It was a bold claim, one that would ignite a firestorm in science. The paper suggested that 66 million years ago, a giant asteroid had struck Earth, scattering iridium-rich dust around the world and triggering the mass extinction. To the Alvarezes, the evidence seemed undeniable, but to many scientists, it was outrageous. For decades, extinctions had been explained by gradual processes: climate change, competition, declining fertility. Catastrophes felt too sudden, too unscientific, almost like myth. Charles Lyell's principle of uniformitarianism, the idea that the present is the key to the past, had shaped geology since the 19th century. Slow erosion, slow uplift, slow evolution. Not apocalyptic rocks from space. Critics pointed out problems. If an asteroid had struck with such force, where was the crater? Others suggested volcanism, especially the vast Deccan Traps eruptions in India, could explain both the iridium and the extinction. Paleontologists argued that dinosaurs were already in decline, citing patchy fossil records. The debates grew heated, filling conferences with tension and journals with rebuttals. But supporting evidence accumulated. Geologists found shocked quartz in the boundary, impossible without massive pressure. They found spherules, tiny glass droplets, scattered in the same clay. Charcoal fragments told of global fires. Everywhere scientists looked, the signs of sudden catastrophe multiplied. Still, the missing crater remained the central challenge. An impact of that magnitude should have left a scar larger than any on Earth. Yet no one could point to it. Some dismissed the hypothesis outright. No crater, no credibility. But others joined the hunt. Seismologists, paleontologists, geochemists, all began looking for a wound large enough to match the theory. The debate shifted from whether to where. The Alvarez hypothesis had planted a seed. Over the next decade, it grew into one of the fiercest controversies in modern science. The answer, ironically, had been hiding in oil company files. In the 1970s, geophysicists working for Pemex, the Mexican state oil company, had mapped a strange circular structure beneath the Yucatan Peninsula. Seismic surveys, designed to locate petroleum reservoirs, revealed an arc nearly 180 kilometers across. Drill cores pulled from the site contained shocked quartz and glassy melt rocks, but the data remained largely unpublished, tucked away in industrial archives. By the early 1990s, academic scientists connected the dots. The structure was precisely the right age, 66 million years. Its size matched the scale of devastation. Its geology showed exactly the kind of impact evidence the Alvarez team had predicted. The Chicxulub crater, named after a small town near its center, had been the scar the world was missing. Confirmation came through radiometric dating, geophysical mapping, and drilling projects. The impact site contained a peak ring, just as models predicted, and layers of ejecta identical to those found in boundary clays worldwide. It was not only a match, it was proof. The discovery transformed the debate. Skeptics could still argue about details, about whether volcanism had worsened the catastrophe, about whether some lineages were already weakening. But few could deny that an asteroid had struck. The crater existed. The fingerprint of iridium, shocked quartz, spherules, and soot was explained. The extinction had a cause. Chicxulub today lies hidden under jungle and shallow sea. From the surface, you cannot see it. But from space, satellite images hint at its curve, a subtle arc in the land and coastlines. Beneath the ground, geologists trace its walls, its melt rocks, its collapsed core. It is a scar deep and permanent, a reminder pressed into Earth's crust. The discovery of Chicxulub was more than the solving of a mystery. It was a revolution in how science views catastrophe. Life does not only fade slowly, sometimes it ends suddenly. The dinosaurs, the ammonites, the pterosaurs, all gone in a geological blink. And so the story of extinction, once told as a slow decline, became a tale of a single day when the sky fell. When the dust finally began to settle, Earth was quieter than it had been in millions of years. The age of dinosaurs had ended, not with a graceful decline, but with a sudden silence. What remained was not only absence of sound, but absence of structure. Ecosystems had collapsed. Food webs, once dense and interwoven, were torn apart. Where herds of hadrosaurs had grazed floodplains, there were only skeletal trees and wind-blown ash. Predator-prey relationships, once predictable rhythms of chase and escape, were severed. In the oceans, ammonites, Keystone species in marine ecosystems were gone, leaving niches empty. Coral reefs, long architects of biodiversity, lay ghostly and pale. To call this emptiness quiet understates its gravity. It was ecological vacancy on a planetary scale. For 150 million years, large dinosaurs had been the dominant consumers of plants and animals on land. With their disappearance, entire roles were left unfilled. The towering browsers, the mid-sized grazers, the top predators. No animal remained to shape forests with trampling feet, to thin herds through predation, to recycle vegetation into soil through sheer volume of digestion. The result was landscapes in flux. Ferns surged into burned ground, carpeting wastelands in green but without the browsers that had once kept them trimmed. Rivers ran clearer for a time, freed from the silt of herds trampling banks. In the oceans, plankton slowly rebounded. But for years the seas lacked the coiled silhouettes of ammonites and the sweeping shadows of mosasaurs. It was a world emptied not of life, but of giants. Survivors remained, crocodiles basking in rivers, turtles crawling across mud, mammals stirring in burrows, but they occupied only fragments of the abandoned stage. The space was open, and in evolution, open space is opportunity. For more than 100 million years, mammals had been cast as minor characters. They hid in shadows, hunted insects by night, and lived in burrows to avoid the claws and teeth of dinosaurs. Their bones in the fossil record are small and scattered, dwarfed by the remains of giants. Now, with the giants gone, the rules changed. The extinction created ecological niches of every kind: herbivore, predator, scavenger, climber, swimmer. Mammals began to experiment. In the earliest Paleogene rocks, we see evidence of a sudden diversification. Jawbones and teeth vary dramatically. Flat molars for grinding plants, sharp carnassials for slicing flesh, versatile dentitions for omnivory. Skeletons show limbs elongating for running, spines adapting for climbing, digits reshaping for digging. At first, they remained small, rat-sized, rabbit-sized, dog-sized. But within a few million years, some lineages grew to wolf-sized, then bear-sized. By the Eocene, less than 10 million years later, there were mammals as large as early horses, primitive elephants, and strange hoofed predators. They filled roles abandoned by dinosaurs, but in new ways, bringing mammalian traits, fur, warm-bloodedness, complex social care, into niches once dominated by reptiles. Brains grew too. Relative to body size, mammals had larger brains than dinosaurs. This allowed more flexible behavior, memory of food sources, problem-solving and finding shelter, cooperative care of young. In a shattered world, flexibility was survival. Fossils show early primates leaping through new forests, ancestors of apes and humans yet to come. The extinction had not been merciful, but it had been transformative. By removing the rulers of the past, it had handed the stage to the small, the adaptable, the overlooked. Mammals did not merely survive. They began to radiate into forms that would define the future. The space left open was not empty for long. Recovery was not quick, but it was certain. Plants, insects, and small survivors stitched new ecosystems from scraps. On land, Paleogene landscapes shifted into stable, multi-layered forests. Dense canopies created shaded underworlds, vines tangled upward, and insect-plant interactions became increasingly specialized. Fossil pollen shows not just recovery, but a transformation. Ecosystems assembling into forms distinct from the Cretaceous past. Forests regrew, this time without the pressure of giant sauropods stripping their crowns or herds of hadrosaurs reshaping the undergrowth. The structure of ecosystems shifted, paving the way for mammals to climb, forage, and adapt in spaces dinosaurs had once ruled. In the skies, birds diversified rapidly. Freed from competition with pterosaurs, they occupied niches across continents: waders in wetlands, divers in lakes, seed-eaters in forests. Some evolved powerful beaks for cracking nuts, others slender ones for probing flowers. Within a few million years, songbirds had emerged, their calls carrying across landscapes that had once echoed with reptilian cries. The oceans, too, rebuilt. Plankton recovered first, tiny but foundational. With them, food chains reassembled: small fish, then larger fish, then sharks and marine mammals that evolved later. Coral reefs returned slowly, their architects new species rather than old. Ammonites were gone forever, but other mollusks rose. The seas remained altered but alive. Geological layers tell this renewal as clearly as they told collapse. Above the iridium clay, diversity returns. Mammalian teeth diversify in fossil beds. Bird bones multiply. Pollens branch into new shapes. It is the record of Earth learning to breathe again. What the asteroid ended was immense, but what it created was space, a void into which life flowed, reshaping itself with every generation. The space left open by extinction was not a wasteland forever. It was a canvas. Upon it, life painted anew. Long before science gave names to dinosaurs, people encountered their bones. In ancient China, villagers dug up massive femurs and skull fragments, grinding them into powders used in medicine. They called them dragon bones, imagining mythical beasts rather than long-dead animals. In Greece, philosophers puzzled over seashells embedded in mountains. How could marine creatures sit high above the waves? Some argued that the world had changed. Others insisted they were tricks of geology, sports of nature shaped by stone itself. The idea of extinction, that a species could vanish forever, was almost unthinkable. Nature, people believed, was balanced, complete. Why would a god or a universe allow creation to simply fail? It was not until the Enlightenment that the truth began to emerge. In the late 1700s, naturalists in Europe studied fossils with new seriousness. The bones did not match any living animals. Enormous jaws with conical teeth were not from whales or lions. Clawed hands and armored plates belonged to no creature wandering the forests. Something was missing, not just specimens, but entire species. The French anatomist Georges Cuvier gave voice to the revelation. In the early 1800s, he argued that extinction was real. Creatures like mammoths and giant reptiles had lived and then disappeared. Catastrophes, he proposed, had swept them away. His ideas sparked debate, but planted the seed of a new worldview. The Earth had lost entire dynasties of life before. By the 19th century, paleontology was born. The first true dinosaur fossils were unearthed in England and named Megalosaurus, Iguanodon, Hylaeosaurus. They were hailed as terrible lizards, rulers of a forgotten era. Yet even as bones filled museums, their ending remained a mystery. Why had such dominant creatures vanished? The fossils kept their silence, but they invited us to ask. Throughout the 19th and early 20th centuries, theories abounded. Some argued that dinosaurs were victims of climate change, unable to adapt as seas shifted and mountains rose. Others believed mammals had outcompeted them, stealing eggs or food. Disease was suggested, or dwindling fertility. The explanations were gradualist, slow and steady, in keeping with the prevailing philosophy of geology, uniformitarianism. The very notion of sudden catastrophe sounded unscientific. Cataclysms belonged to myth and religion, not rational inquiry. Scientists preferred to imagine dinosaurs fading gently into obsolescence, replaced by fitter forms. Yet the fossil record contradicted this. Dinosaurs were not rare at the end of the Cretaceous. They were abundant and diverse. Their disappearance was abrupt. The 20th century brought new tools. Radiometric dating placed the extinction at around 66 million years ago. Ocean cores revealed sharp declines in plankton. Charcoal layers hinted at fires. Still, the cause remained elusive. Then came the discoveries of the late 20th century. The iridium-rich boundary, the glass spherules, the shocked quartz. Together they pointed to an asteroid impact. The Alvarez hypothesis, controversial at first, gradually gained support. And when the Chicxulub crater was confirmed in the early 1990s, the mystery was solved. For humanity, this was more than an academic triumph. It was the recognition that our planet is not a closed system. The sky, which had once seemed a distant decoration, is an active player in our fate. The same heavens that inspire poetry also deliver destruction. The dinosaur's end was not a parable of weakness. It was an accident of geometry, a rock and a planet crossing paths. And in that accident lay the seed of our own existence. Without it, mammals might never have risen, primates might never have flourished, humans might never have stood beneath the night sky wondering what had happened. The discovery rewrote not only prehistory, but our understanding of chance and survival. The story of the dinosaurs' extinction is not only a tale of the past, it is also a mirror held up to our future. We now know that Earth orbits in a solar system filled with debris. Asteroids cross our path regularly. Most are small, burning harmlessly in the atmosphere. But some are mountains in waiting, silent as Chicxulub once was. The probability of another large impact in human timescales is low, but not zero. The boundary clay is a reminder that low is not the same as never. In response, humanity has begun to act. Astronomers scan the skies, cataloging near-Earth objects, tracing their orbits, calculating risks. Missions test our ability to deflect a rock with spacecraft, nudging it ever so slightly off course. Planetary defense has become not science fiction but policy, a recognition that survival sometimes requires looking upward. But the story resonates more deeply than technology. It tells us how fragile dominance is. Dinosaurs ruled for 150 million years, far longer than humans have existed. Yet their supremacy ended in a single day. If it happened to them, why not to us? It also reminds us of the contingency of our own story. Without that asteroid, mammals might never have risen. Primates might never have thrived. Our species might never have appeared. Every tool, every city, every word is balanced on the absence left by dinosaurs. Our civilization is, in a sense, the echo of their extinction. Standing at the edge of a cliff, with the thin KP boundary visible as a line of clay, one can place a hand upon it and feel the hinge of history. Below lie the bones of giants. Above, the seeds of our own story. That line is not just geology. It is destiny written in dust. And so the human discovery of the dinosaurs' end is also a discovery of ourselves, our luck, our fragility, and our responsibility. The sky once erased rulers greater than us. One day, it could do so again. The question is not only what killed the dinosaurs, but whether we will be wise enough to learn from them. In the immediate aftermath of the extinction, the world was stripped bare. Yet even as darkness lifted, life carried in its seed the ability to begin again. Ferns were the first to reclaim the land. This early Paleogene pioneer plant phase is found globally, a green tide flowing into the black void left by fire. But the fern surge was only transitional. Within a few million years, expansive forests of palms, hardwoods, and novel flowering trees created dense, tiered habitats that became laboratories of evolution for insects, birds, and mammals. Pollen records from the Paleogene show sharp increases in diversity. In North America's Hell Creek Formation, layers above the boundary reveal early Paleogene forests filled with willow-like trees and sycamores. In Europe, subtropical forests bloomed in what are now chalk cliffs. South America sprouted vast palm groves. The regrown forests were not carbon copies of Cretaceous jungles. Without sauropods stripping treetops or ceratopsians clearing ground cover, vegetation followed new rules. Dense canopies formed with multiple layers of foliage. Shrubs and vines spread unchecked. Insect populations followed suit. Beetles, ants, and flies adapted to pollinate new flowers. Bees, already ancient, expanded in step with angiosperms, forging a partnership that continues today. This renewal reshaped Earth's climate too. As forests returned, they pulled carbon dioxide back into biomass, stabilizing the greenhouse effects that had wavered after the impact. Streams filled again with leaf litter, feeding aquatic insects and fish. Soil thickened with humus. The scars of the catastrophe lingered. Charcoal layers, acidified lakes, stripped valleys. But in green shoots pushing through ash, the Paleogene world began. It was not the same planet, but it was alive. The skies were forever changed. With the pterosaurs gone, birds inherited the air. The avian survivors of the extinction were small, ground-dwelling species, often seed-eaters. From these humble forms came an astonishing radiation. By the early Paleogene, fossil deposits show new bird groups proliferating. In North America, waterfowl-like species swam in recovering lakes. In Europe, forests hosted early parrots and perching birds. In Antarctica, then warmer than today, fossils reveal large, flightless birds striding through lush landscapes. Birds reshaped ecosystems. As forests recovered, they became dispersers of seeds, swallowing fruits and depositing them far afield. Their beaks diversified, crushing nuts, sipping nectar, catching fish. Some lineages grew large and predatory. In South America, the infamous forest racids, or terror birds, evolved to 3 meters tall. With hooked beaks and strong legs, they became apex hunters in ecosystems temporarily lacking mammalian predators. Their reign lasted tens of millions of years. But it was not only size that defined the new avian age, it was song. Fossil syrinxes, the voice boxes of birds, appear in the early Paleogene, suggesting that complex vocalizations evolved soon after recovery. Where pterosaurs had screamed in reptilian tones, birds whistled, trilled, and eventually sang. Their voices filled forests that had been mute for millennia. This diversity is captured in layers of bone and beak, but also in the ecological imprints they left. By dispersing seeds, controlling insect populations, and becoming prey for mammals, birds knitted themselves into the fabric of Paleogene ecosystems. The empty skies of the post-extinction Earth did not remain empty. They became louder, more colorful, and more intricate than ever before. On land, mammals answered the vacancy left by dinosaurs with evolutionary fireworks. Before the asteroid, they had been minor players, mostly small, nocturnal insectivores. Afterward, they began to expand in body size, diversity, and ecological role. In the Paleocene, 56 million years ago, fossils reveal an extraordinary burst of mammalian innovation. Jaw fragments, once uniform, display new specializations: shearing teeth for carnivory, grinding molars for herbivory, versatile dentitions for omnivory. Skeletons show limbs elongating for running, spines flexing for climbing, claws shaping for digging. Within just a few million years, mammals filled niches dinosaurs had dominated for ages. By the Eocene, 34 million years ago, the transformation was complete. Forests sheltered primates with grasping hands and stereoscopic vision. Open plains carried hoofed herbivores, the ancestors of horses, deer, and cattle. Predatory creodonts, and later true carnivores, evolved to hunt them. In the seas, some mammals returned to the water. Fossils from Pakistan and Egypt show primitive whales, with hind legs still attached, learning to swim. These lineages would evolve into today's dolphins and blue whales. Brains expanded too. Mammals already had relatively large brains compared to dinosaurs, but in the Cenozoic, encephalization accelerated. This granted learning, memory, and social complexity. Herding behavior, parental care, and cooperative hunting all grew in importance. The mammals' rise reshaped ecosystems. Grazers influenced plant communities, keeping landscapes open. Predators checked populations, creating balance. Burrowers mixed soils. Mammals became the engineers of the Cenozoic, sculpting Earth as profoundly as dinosaurs once had. Among these lineages were primates, small at first, but gifted with agility and curiosity. From their survival would eventually come apes, and from apes, humans. The asteroid had not only ended one story, it had cleared the stage for ours. The new world of the Cenozoic was not merely recovery, it was reinvention. From these early radiations came the primates. In tropical forests of the Paleocene and Eocene, small, agile mammals with grasping hands and forward-facing eyes leapt from branch to branch. Their diets were mixed: fruits, insects, leaves, granting them flexibility in unstable ecosystems. Fossil genera, such as Purgatorius in North America and Tailhardina in Europe, represent the dawn of a lineage that would one day include apes and eventually humans. This connection is humbling. Our story does not begin with tools or fire or language. It begins here, in the silence after catastrophe, when mammals seized the ecological space left by dinosaurs. Without the asteroid, primates might never have risen. Without primates, no humans. The new world of the Cenozoic was not only a renewal of forests and oceans, it was the beginning of the conditions that would eventually give rise to us. Every city skyline, every scientific discovery, every song and story is built on the foundation laid in these Paleogene forests by creatures no larger than squirrels but carrying within them the potential of humanity. 66 million years ago, the asteroid struck Earth at precisely the wrong time. Had it arrived a few minutes earlier or later, Earth's rotation would have carried a different surface beneath it. Instead of shallow seas rich in sulfur-bearing limestone, it might have hit deep ocean or barren rock. The outcome could have been different. Less vaporized rock, fewer aerosols, perhaps no global winter. Dinosaurs might have suffered, but they might not have vanished. The margin was razor thin. A delay of seconds, a shift of degrees, and history could have diverged. Instead of mammals rising, the age of dinosaurs might have continued, their descendants filling niches that mammals later claimed. Primates might never have appeared. Humans might never have existed. This is the unsettling truth of deep time. Chance shapes destiny. Evolution is not a ladder, but a branching tree pruned by accidents. The asteroid was not purposeful. It was geometry, an orbit intersecting another orbit. Yet from that blind event came everything we know, the songs of birds, the shapes of mammals, the thoughts in human minds. The fossil record is a library of contingencies. Each extinction is a chapter break, each survival a fragile bookmark. The asteroid was one such bookmark, dividing eras with a line of clay. Below it, the giants roam. Above it, mammals rise. Between them lies the thin chance of impact. It is humbling to imagine that our existence is the byproduct of a rock in space, and it is haunting to realize that chance remains at work. The same sky that ended the dinosaurs still holds debris. The story is not over. From Chicxulub, humanity inherits a lesson. Dominance is fragile. Dinosaurs ruled for 150 million years, 25 times longer than humans have existed. Their reign seemed eternal, but it ended in a single day. Supremacy does not guarantee survival. We stand at our own crossroads. Our threats may not come from the sky, though asteroids remain a possibility, but from within. Climate change, biodiversity loss, nuclear weapons, pandemics. Each is a stress we have created or amplified. Unlike the dinosaurs, we can foresee them. Unlike them, we can act. Science has given us tools to detect and even deflect asteroids. Missions have demonstrated the possibility of nudging rocks from their paths. But science also warns us of slower catastrophes, rising seas, shifting climates, collapsing ecosystems. The asteroid reminds us that catastrophe need not be gradual. It can be sudden. Our responsibility is to recognize both tempos, the instant strike and the creeping change. There is another lesson. The survivors of the Cape were small, adaptable, and opportunistic, traits that recur across evolutionary history. Mammals that ate many foods, birds that cracked seeds, turtles that waded in ponds. Those traits, small body size, dietary flexibility, and opportunistic behavior, were sufficient to carry lineages across the boundary. For us, the analogy is sharp. Survival will not belong to the richest nations or the strongest militaries, but to societies willing to adapt, cooperate, and endure. Dinosaurs remind us, the measure of success is not how high we rise, but whether we last. The boundary clay is a mirror as much as a record. When we look into it, we see not only the death of giants, but the question of ourselves. Every extinction is an ending, but also a beginning. The asteroid ended the age of dinosaurs, but in that space, mammals rose, forests shifted, birds sang new songs. Our very presence proves that endings can seed beginnings. But this truth cuts both ways. If chance gave us existence, chance can take it away. Somewhere in the sky, asteroids still wander. Somewhere on Earth, systems creak under human pressure. One day, another line of clay could be laid down, and above it, no trace of us. What would follow? Just as mammals stepped into the void of the dinosaurs, something would step into ours. Perhaps other mammals, rats, pigs, dolphins, would inherit the world. Perhaps insects, with their resilience and numbers, would dominate. Perhaps entirely new forms would rise, unrecognizable to us. This is the haunting question. Are we the culmination, or just another branch pruned by time? If the asteroid had missed, we would not be here. If another comes, will something else take our place? The stone at the KPG boundary does not answer. It only reminds. It tells us that no rain is forever, no species immune. It whispers that life will go on, with or without us. And so we stand beneath the same sky that once carried death for the dinosaurs. We build telescopes, launch satellites, debate our future. We tell stories of dragons and worlds ending, but in the silence between those stories lies the question the Earth itself asks. If the dinosaurs' time could end in a single day, what will end ours, and what might begin after?